everybody. My name is Martijn and welcome at Igloo. And a very warm welcome at the first ever WAES Tech event. On behalf of the entire WAES team, I would like to say thank you for taking the time and being with us here today. And when we do something, we do it big. So this is why we invited Josh Long, Spring Guru. Please keep in mind that afterwards we also have foods and drinks and of course a meet and greet with Josh. And for now, please enjoy the tech talk and see you afterwards. Thank you.
We are WAES, Dutch software consultancy company. Offices in Eindhoven and Amsterdam, hiring the best engineers from all over the world. On a mission to become the knowledge house of the Netherlands. We heavily invest in the professional development of our heroes. And now, you get to be part of the first WAES Public Tech event. Give it up for Josh Long.
All right, good stuff. I've got this thing in my mouth. All right, now. So, I appreciate you all being here. We have a very little amount of time. We have a lot of things to get through, so let's get to it. First of all, as always, I encourage you to note the coordinates on this deck, on this slide. This slide contains all the information that you need to be able to find me on the internet, and more importantly, to find the code on the internet for your own discretion, for your own reference for later on. So if you have questions, comments, feedback, whatever, don't hesitate to reach out to me. I'm always happy to engage. I'm on the internet. How many of you are on Twitter? I'm just curious. Twitter, 2019. Twitter, 2019. Twitter. Okay, the rest of you, what's the deal? Get on it. It's a great place to be. It's the new IRC. It's where the developers that drive the open source that power your business are, and you owe it to yourself to be there. I am happy to be there. I'm also direct messageable, so you can send me messages. I don't have to follow you or anything. It's just wide open. So if you have questions, queries, whatever, like I said, Twitter. What about email? What about email? How many of you are using email? Email. I'm not a big fan. Not a huge fan, but I prefer to Slack. Anything over Slack, I think is a big deal. So I've had to soften my stance on with respect to email. I don't know if you can see it here, but I have a brand new shiny 2018 MacBook Pro, right? And I bought this with my own cash, my own hard-earned cash, because I thought, well, it's a fancy new machine. It'll have all the specs I'm going to need. It's 32 gigs of RAM, 1 terabyte SSD. You know, worth it, right? Worth it. Nice machine, really indulgent machine. And I thought, well, this will finally be the one. This will be the one that I can finally use to run Slack. And I can't. I can't. It's not fast enough. But did you see the new Mac Pro that they announced the other day? A Mac Pro with 1.5 terabytes of RAM. I think we might be able to run Slack on this. We're almost there. So I'm so excited about this. Anyway, a little bit about me. My name is Josh Long. I'm a Spring developer advocate on the Spring team. I have been for almost 10 years now. I'm very happy to be here, but as part of my work, I get to come to beautiful places like Eindhoven, all around the world, and I talk to people. In China, they made a little toy out of me, which I thought was kind of cool. I do a book. I wrote a book in 2017 called Cloud Native Java. Any of you have heard of it? Maybe? So Cloud Native Java is all about how to build applications that survive and thrive in the cloud in terms of Spring Boot, Spring Cloud, and Cloud Foundry. And I have a new book called Reactive Spring. And this book is the one I'm working on right now. It's a book on which I've been toiling long and hard. And it's pre-orderable already. You can buy it right now. And you are entitled to the final edition when it's done, but you can you can start reading it now. And there's already a couple hundred pages there, so it's not trivial. The book is all about how to build reactive applications in terms of Spring. And I want to sit here and say that this is a brand new thing. I want to say that this is a completely new thing that is just cutting edge. But in actuality, reactive programming is a new response to an old problem. Okay, it's a new response to an old problem, and even the response itself is not that new. Namely, the problem is, how do we scale? How do we handle more users in light of the sort of avalanche of new API-driven applications, client-side applications like mobile and iOS, Android, iPhone, iPad, PlayStation, Xbox, Roku, that one person using Windows Mobile. In light of all these things, we've got more and more demand being foisted upon our servers. And we also see Internet of Things, IoT. We have these new devices, this proliferation of devices that create increasingly a large amount of demand on our servers. All these things result in more API requests going into our servers. And so the question is, how do we handle more capacity? How do we handle more users? The days of yesteryear when we could render an HTML page and the CSS and images that went with it, and that was it, those days are long gone, aren't they? Right? We can't just sit there and assume that a page that's rendered is all done rendering, right? There might be JavaScript and HTML5 in the back end, and those are going to make continuing and ongoing requests into the back end of the API. There's always network traffic happening. Always. So our traditional approaches to scaling no longer serve. They no longer suffice. We can't just use a Java I/O input stream and sit there to process the data. Think about what happens in the heart of a traditional web server. You've got a while loop that says, while server socket.accept does not equal false, right? As soon as you're able to accept an incoming socket, you get the input stream from that socket, and you start reading the data that comes in the socket, and you start producing data in the output stream. You send it back to the client. That's the heart of all basic web servers. And as you're doing this, you're taking time, right? You're sitting there waiting for the input stream, waiting for the output stream to do its work, and you're sitting there on that thread. Well, this is a problem, isn't it? Because it takes a little while to do that. Because in order for you to do that, you have to then make other network calls. You call a database, you call another web server, you call other microservices. So you're sitting there wasting time, idling on these threads. And that's a bit of a problem because threads are expensive. Threads are very expensive on the JVM. Each one of them takes about 1 megabyte of context associated with them. So you don't want to just create threads nilly-willy. You can't really, actually. Suppose you tried to create 1,000 threads on the JVM. Is that going to work? No. First, each one takes about 1 megabyte of context. So, you could be out of a gig of RAM before you've done anything. You created the thread pool and you're already in trouble, right? Extra RAM. And then, even if you did have 1,000 threads, could you do 1,000 things concurrently at the same time, truly concurrently? Clearly not, right? Beyond the number of CPUs, beyond the number of cores, you don't truly have actual concurrency anymore, do you? It's an illusion. It's how fast you can move work onto one CPU and then off again as quickly as possible. You're simulating it. But that movement of work onto the CPU and off again, that's a context switch, and it's expensive. So can you context switch 1,000 times per second meaningfully? No, quite the contrary. And in fact, in adding this context switch to your code, or context switches, in adding that to your code, you've now actually, in a way, made your system slower, right? Your ability to respond per transaction has gone down, but now you've also got a lot of this context switching that's occupying your sort of available bandwidth. So that's not a real scalable option. So how do you solve this? How do you handle more users? Right? What's the best way to handle more users today? What? Yes, more servers. Exactly. That's my favorite answer because I work for a cloud computing company and we sell servers. We love it when you say, I need more servers, right? I love that. Have you ever gotten a server error from a serverless function? How's that possible? Anyway, these are the things that keep me up at night. So yeah, that's my favorite answer, and it's a pragmatic answer. To be fair, it's not that expensive. Cloud computing has given us, per hour, per minute, per microsecond billing. It's crazy, and it's not that expensive compared to standing up a new server, and installing a new pizza box server in a rack somewhere in a data center. Been there, done that. Thank you. Right? Infinitely preferable to that, and certainly much easier. If it dies, who cares? You just move on. Just get a new one. Or the platform will do it for you. It'll move you on to a new one anyway. But it is a bit of a half step. It's very pragmatic because it allows us to take this code that was written in yesteryear and easily scale it out, assuming, of course, that you've written your code in such a way that it is cheap to scale out. Right? You have to embrace 12-factor microservices. You have to keep as much state out of the service as possible. Move that to the back end, something like Cassandra or whatever that scales out. Right? That's the original sort of Netflix definition of a cloud-native microservice, Cassandra and stateless APIs, stateless HTTP APIs. Works fine. right? If you can do that, if you are doing that, and I'm not saying you all are, some people still have monoliths, and that's a discussion that they should have with themselves and their code base. I get that. That's what the old book is about, right? I completely get that that's not a done deal. But if you've made that jump, if you're now on the other side of that jump and you've got microservices and you're prepared to sort of eke out as much efficiency as possible, or if, put another way, you want to handle more users, right, for the same amount of money, then there's got to be a better way. And so let's revisit that while loop. We're spending time on that thread. The only reason we need more threads is because we're on those threads that we've got. We're already using them. And so or in order to handle more capacity, we create more threads. What can we do to get off of those threads? Well, if what you're doing is CPU bound, if it's things like Fibonacci, or cryptography, or Bitcoin mining, or running Slack, don't run Slack, right? If that's what you're doing, then there's no help for you. There's no way to robe reactive on that and get it to go faster. It's just going to be slow. That's a bummer, right? In which case you might want to get more servers or find a way to excise that slow path from your code. But if what you're doing is input and output bound, then there's hope. There's hope. Input and output is, there's two kinds of input and output these days. There's synchronous blocking input and output, the one we just talked about a minute ago, and there's asynchronous non-blocking input and output. Is this a new idea? No, of course not, right? It's been in Java since 1.4. Who knows when 1.4 came out? Java 1.4. 2002. Yeah. You get a beer, but you already got one, so, 2002, it came out. And if it's been in Java since 2002, 17 years, right? If it's been in Java since 2002, that means that it's been readily available and workable on all the operating systems on which Java runs, right? So Linux, Mac OS 9, and OS 10, right? 11? What? There's 11? I don't know. I'm talking about 2002 era, right? Windows NT, all Windows XP, whatever. All Windows, actually. Windows. I expected it to work on Linux and Mac and all that, but Windows. 2002. Windows. It's crazy. Crazy. Wonders will never cease. Now, I mean, it's kind of cool. So the point is, if it's available in Java since 2002, why aren't we all using it? What's the deal? Why aren't we all building on top of that abstraction? And I would argue that it's fairly obvious. The reason we're not building on this abstraction is because we don't build on top of synchronous and blocking I/O directly anyway, do we? Most of us don't work at that level. Hopefully, you don't go to work every day and say, I'm going to write code using a Java input stream and output stream. You're going to handle your security problems using input streams and output streams. Do you do data access with input streams and output streams? Do you build your network services using input streams and output streams? Well, special guy. I think most of us are very much the exception, right? We don't do that, right? We are people that work with abstract frameworks that allow us to think about our business logic and let the lower-level plumbing be handled by something else, something lower level, like a framework, okay? That lets us focus on the thing at hand, the task at hand, and the rest of it gets managed for us. Now, those frameworks have traditionally been just fine. They've served us just fine, and they work in terms of the metaphor that they're built on, right? So they, in turn, build on things like the servlet spec and JDBC. And these things, in turn, assume synchronous and blocking I/O. So we're so far removed from that decision that we really haven't had to think about it. And to be fair, before the proliferation of IoT and these mobile clients and big data and all these things and microservices, we didn't have to think about it. There was nothing wrong, right? Most of us could handle the scale we had with ease. But now we have faced a turning point. Now we have a good deal, many more requests to handle. And so the question is, what can we do? Well, if we take advantage of asynchronous I/O, what we're dealing with is a new inverted style of working with data. Instead of asking a thing for data, instead of pulling the data out of the input stream, the data gets pushed from the stream to the consumer. And so we've got a very inverted style of working. It's a push instead of pull model. So whatever computational metaphor we use to work with that data has to support this new inverted paradigm. Instead of pulling the data when we want it, we just are given the data when it's there, and it's up to us to do with it what we will, right? It's a callback-centric world. This callback-centric world is great, though, because it allows us to think about larger, potentially unbounded streams of data. It allows us to say, there's latency in this data. It's not here right now, but I don't expect it to be here right now. It'll be here in a second, maybe a nanosecond, maybe a week. Who knows, right? That's okay. Once you've decoupled, once you've introduced temporal decoupling, once you're no longer saying, my client needs to be at the same place as the producer for the data, I can go ahead and do something else in the meantime while I'm waiting for that data, things become interesting, right? Asynchronous programming is a very powerful paradigm, but can be a little twisted. I think that's why they call that Python framework twisted, right? Makes your head twist. You've seen what happens to those poor Node.js developers. They end up with 500 lines of indents and then 500 lines of dedents because of the nesting. Anyway, point is, we've got this programming paradigm. There's a paradigm that's built on top of this new idea of you taking advantage of asynchronous I/O. Asynchronous I/O gives us the ability to work wonders with our scale, but it does require a slightly different, slightly more convoluted programming style. What we need are computational metaphors that make this as easy as possible so that people don't get lost trying to understand what's happening. So enter the reactive stream specification, which was introduced, I don't know, 3 or 4 years ago. It's the common ground specification from a number of different organizations. It includes Pivotal, Netflix, Eclipse Foundation, and Lightbend, among others, right? These different organizations got together and they extracted out 4 very simple interfaces that map nicely to this new asynchronous inverted sort of style, okay? These things are, I think, particularly nice. They're elegant. They're so elegant, in fact, that they've since been added into the JDK, right? They're actually in Java util concurrent flow, right? So they plug a gap that was not hitherto sort of filled. That's good, right? We need them. But they're very, very low level. Think of them as being sort of discontiguous arrays, right? Whereas arrays are contiguous chunks of memory, and they're synchronous. They're all sort of in one place at one time. You can think of the reactive stream specs as providing a discontiguous array. It's a very low-level holder or very low-level thing that you can use to get access to data. It doesn't give you much else beyond that, though. There's no operations, no flat mapping, no filter, no map, none of this stuff. So on top of that, we need something more sophisticated. And so different projects like Reactor from Pivotal, like Arcs Java from Netflix, like Akka Streams from Lightbend, and like Vertex from the Eclipse Foundation, all provide operations and pipelines on top of that, okay? And this also implies interoperability because they all build on top of these, or support these reactive streams types. Is that enough? Are we done? Can we go to production yet? I'd say no. I'd say of course not. I'd say because we're not done. We haven't actually, we've got to the point where we can now describe streams of data, but we're not building software. We're not shipping to production yet. Imagine, for whatever reason, that the frameworks with which you're familiar, things like Hibernate, things like Spring MVC, imagine that for whatever reason, these technologies, the ones with which you're familiar, the ones with which you've got experience for the last several years, or 10 years, or 15 years, imagine that these technologies, for whatever reason, really, really hated Java util collections. Just really hated them. They were hostile to them. Imagine whenever you tried to use a Hibernate entity and you created a one-to-many relationship. Imagine for whatever reason that whenever you created a one-to-many relationship, Hibernate didn't just throw an exception. It didn't just throw an exception. It actually rendered an ASCII art middle finger. And then segfaulted the machine. Kernel panicked right there, just to show you how mad it was. Would you continue to use Java util set and Java util list in your Hibernate mappings if you knew that you could expect this kind of abuse? Of course not, right? You'd use the path of least resistance. You'd use whatever the framework suggested, whatever it recommended, whatever the best path forward was. If that's some other type, so be it. You'll use that. You have to get software into production. Your job is to get to production, to deliver value for the business. You're not in the business of recreating Hibernate, so that's not a hill that you want to die on, right? You're not going to re-implement Hibernate just to get your lists. No. You'll just use the best way to get to production. The same is true here. What good are these reactive types if nothing supports it, if we can't do anything useful? I don't want to spend my day at the lowest level still trying to build network services when I could be building business software, right? So, for the Spring team, a big part of our journey came in September of 2017 when we released Spring Framework 5. Spring Framework 5 is the first release of Spring to integrate as a sort of end-to-end experience the reactive support provided by Reactor. It introduces a brand new, net new reactive web runtime called Spring Web Flux. Spring Web Flux is, well, it's just that. It's a reactive web framework. On top of that, we have since released Spring Boot 2.0, Spring Data K, Spring Security 5, and Spring Cloud Finchley, and a number of other releases besides and beyond. All these things are now provided for you, and they allow us to build end-to-end systems with microservices. And that, my friends, is the journey that we're going to trace today. We're going to follow those technologies, see what they can do for us today, and what they're going to do for us tomorrow. Oh, look at that chair. Good stuff. Oh, yeah. Good stuff. So, goodbye. Okay. So, what we're going to do is we're going to build a new application here at my second favorite place on the internet after production. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and WebSphere, start.spring.io. So we're going to build a brand new application here. We're going to build an application using Spring Boot. I'm going to use the latest and greatest version of Spring Boot 2.20 M3. I'm going to bring in some dependencies here to support what I'm trying to do, namely the Spring Web support. I'm going to bring in Lombok. I'm going to bring in the Reactive MongoDB support. I'll bring in RSocket. And I think that's it for now. That suffices for now. So Spring Reactive Web, Lombok, Spring Data, MongoDB, and RSocket are just the beginnings, but that'll get us started, and that'll allow us to build software that I think is kind of interesting. Now, there are a few things that I think you should consider when you make your choices here. Go to the Options menu and choose the latest and greatest version of Java that's running on your machine. It should never be 8. If it is, that's the wrong answer. You should stop and install a new one. Uninstall 8 and then proceed. I'm not saying that there's a moral connotation or argument to be made here, but you're a bad person if you use 8. It's not moral, it's just the facts, okay? Because people are still using it, and this is the problem. I'm doing my level-headed best to lead the charge here, and you need to help me make this work. We can't have people on Java 8. It's dead. It's dead. It's end of life. It's deprecated. It's no longer supported. Expired, defunct, smelly. It needs to be gone. And this is why I'm spending time here to make sure we understand how to override it. Okay, so use at least Java 11. That's the latest long-term supported version. And use OpenJDK. If you have a question, what with all the recent turmoil around licenses and stuff, truly, don't sweat it. Just use OpenJDK. You'll be fine. Okay. So we've got a new version here. You can use other languages, Groovy, Kotlin, and Java, etc. And then the question, of course, is the choice of packaging. People get confused by this. They don't know when and where to choose which. So I'm going to do my level-headed best here and now to explain when and where to use which option. If by some fluke of physics, you should find yourself somehow trapped in the distant past, far, far, far beyond modern help, then choose .war. But if you're here with me in 2019, then choose .jar. This is a big part of my overarching and guiding personal philosophy of make jar, not war. And again, lots of options, lots of things you could do, but I encourage you to stick with a useful default here. Okay? So I'm going to hit generate. That'll give us a new project. Yes, sir.
Can you comment, please? When will you drop Java 8 support?
When will what?
When you will drop Java 8 support to be known?
I don't know. As soon as we feel it pragmatic, we really want to. It would be great if the community would. We know that a lot of people come and they choose that version, and we know that a lot of people are still using it. But I really, really want people to stop. Right?
What do you expect, like your personal?
People are. I don't know that there's a lot of I don't know that there's a lot of like user-facing features to compel people to move to Java 11 right now. I think there's a lot of interesting things that are behind the scenes that are compelling. I think the speed it gains, I think the operational ability of it is great. But in terms of developer syntax, there's not all that much yet. Now Java 12, that's a little bit more interesting. You've got enhanced switch statements in preview. You've got var in Java 11. So there's some good stuff, but not nearly the jump, not nearly the leap forward that Java 8 was. So, you know, we'll see. Let's see what happens. But in the meantime, we should get on the train. Any version after Java 9, or Java 9 or later, is going to be super easy to upgrade. It's Java 8 to 9 that's difficult. So make that jump, and then you won't have any fear of doing it. You're going to see everything I'm going to do today just works just fine on Java 11 or Java 12. And Java 13, we already test against that too. So we now have a new project. I'm going to hit generate. Here we go. Okay, I'm going to open this up in my IDE. And this is going to be, you can use any IDE you want. I'm going to use IntelliJ. Anything works just fine. Anything works just fine, right? Spring assumes a Java 8 baseline, by the way. We just recently, as of Spring Framework 5, which we released in September of 2017, dropped support for Java 6 and 7. Right? We do have a long tail for backwards compatibility, but hopefully that tail should become a smaller and smaller tail. We want to see people moving to the front of the line as fast as possible. So we have a Java 8 baseline requirement for Spring. So as long as your IDE supports Java 8 and Maven or Gradle, you're going to be fine. Now, Spring Tool Suite supports it, right? IntelliJ, NetBeans supports it. I used start.spring.io from the browser, but did you know that you can also use it from the command line? Start.spring.io. Whoops. HTTPS, because it's the future. Okay. So there it is. Right? There's all the different dependencies. And if you want like a web app using Java 11, which you do, this is the one you should use, right? And it adds the web support, et cetera, et cetera, et cetera. So there you go. So you've got that. You can also go to your IDE, start that, file new, Spring Starter project and STS. NetBeans has one as well. IntelliJ has one as well. All these different tools have a way to invoke the start.spring.io experience from the IDE, but they're actually calling the same web API. So whatever your choice, right? Okay, so now we're inside of IntelliJ. What we're going to do is we're going to build an application that writes data to the database, and I'm going to be using MongoDB in the background. I have MongoDB running on my local machine. Let's confirm that here. Good stuff. I'm going to drop my table called reservation. Okay, drop. Good. Good. So this is my entity. I'm going to create that. I'm going to make it a document. A document is a single row in a collection for MongoDB. And a collection is like a table. I'll have a field called ID and another field called name. At ID is the document key. Okay. Now this is Java, so what I want is getters and setters and toString and all that good stuff. And I'll do equals and hash code. Oh yeah, look at all that. toString, good stuff, right? So we've got all that garbage. Just look at it. Just so modern, so Java. So instead of doing that, I'm going to use Lombok. Lombok is a compile time annotation processor. I'll say at all args constructor, no args constructor, and there we go. Now I've got the different types, and I want to be able to work with instances of the data in a repository. And a repository, of course, is a design pattern that borrows from the seminal tome by Eric Evans called Domain-Driven Design. It's a book that espouses good, clean architecture, and a repository in that book is a thing that insulates your business logic from the tedious, soul-annihilatingly boring lifecycle management of entities. This repository should look very familiar. It has the usual suspects, things like save, save all, save, find by ID, giving it a publisher, check if it exists, find all, delete, count, etc. The names should be fairly straightforward, but what I think may not be straightforward are these types. The first and most important of which is a publisher. A publisher is a thing that, it publishes, right? It's in the name. It publishes. So it publishes things of type T, where T could be a byte, a customer, a string, a line item, an order, whatever. Anything of which you have a stream. It publishes those things to a subscriber. The subscriber subscribes to the data. we're going to come back to the onSubscribe method, but the first thing that happens is when the subscriber subscribes to the publisher, it is given a subscription. We'll come back to that in a second. When data arrives, eventually, in 1 nanosecond or 1 year, right? It doesn't matter. There's no prescription here. When the data arrives, it's passed into the It's passed into the onNext method. When there are errors, as will happen in a distributed system, something you should be very prepared for, then the onError method is called. OnError is your opportunity to deal with errors in the same way as you deal with regular data. In reactive programming, it's sort of functional programming. It's kind of functional. And so we think about errors as just another kind of data. They're not treated any specially, right? The same operators, the same flow is used to deal with errors. And there's no separate control flow case. Errors, quite contrarily to the sort of intent of the Java language designers, are not exceptional, okay? When we complete processing, we call onComplete, or rather the publisher calls onComplete. That's the signal that we're done processing the data. Now, I kind of skipped over onSubscribe. Let's return to that. OnSubscribe is where the subscriber is given a reference to a subscription. A subscription is a thing that each subscriber gets. It's unique to each one. You can have multiple subscribers. And it is a thing that the subscriber uses to push back on the producer. A subscription gives us the ability to say, hey, I want 10 more records, but not more than 10 records. I want 1,000 records. And what you're saying is, publisher, dear publisher, don't give me more than 10 things at a time. It could be 10 things all in the same nanosecond, or it could be 10 things over 10 years, right? But you won't get more than that. After the 10th item, it's up to you to request more. And if you're not prepared to handle more, that's okay. Don't request anymore. You can slow down the rate of consumption. Or if you just want to be done with it altogether, you're tired of this darn publisher, it's giving you nothing but trouble, you can say cancel. Now this is just basic flow control, something with which you've all wrestled if you've ever had to think about network programming, right? If you've ever since one computer was on the same network as the other, we had this issue of flow control. This is a very basic idea. It's fundamental to what we're doing in the world of distributed systems. And yet we don't think about it because most of us spend our time at the top of the abstraction stack, at the very tippity top of the abstraction stack, so far removed from this that we don't get a chance to sort of weigh in on that, so to speak. With reactive programming, it's a part of the API. You must confront it, you must acknowledge that it's there, and you have the ability to work with that to your benefit. Flow control in the world of reactive programming has been rebranded, remarketed as back pressure. Okay, it's a marketing term, but hey, if that helps you remember what this is, great, okay? You can see that we've already covered 3 of the 4 types. I told you there are going to be 4 types. We've got publisher, subscriber, and subscription. The 4th type is a processor. A processor is just that. It's a bridge. It's a source and a sink. It's a producer and a consumer. It's a link between both sides. That's it. There you go. If you understand these 4 types, these 4 very simple types, congratulations, you're certified reactive. Go to Silicon Valley, raise millions of dollars, burn it all in stupid parties and VC parties, and then come back in 6 months a failure. You're ready. You're ready, okay? Silicon Valley awaits you. You're already years ahead, light years ahead of any of the script kiddies in Silicon Valley that have no idea how to build software, right? I believe in you. But as you can see, these are fairly Spartan APIs. These are very low-level APIs. Like I said, discontiguous arrays, not much more. So we need specializations, things that allow us to do more with less. Of which mono, which by the way is, for those of you who are Spanish speakers, that's not monkey. Mono is a thing that produces at most 1 value. It's a publisher. It's a specialization of publisher, right? There it is. But it's a thing that produces at most 1 value. It's like a completable future, except that it has back pressure. There's also flux. Now, you may not give a flux, but I think that this type is a very interesting type. It's a thing that allows us to work with streams of data, potentially unbounded streams of data, 0 to infinite, right? Could be 5, could be 2, could be a billion, could be infinite, right? They're both publishers. But one is more like a Java 8 stream, but with back pressure, and it supports a push model instead of a pull model. And one is like a completable future, but with back pressure. Okay? These types are super useful. The reactive stream types are super useful. And I think these specializations are very useful as well because they give you operators on which to, with which to operate on streams of data. Things that support flat mapping and mapping and filtering and composition and functional things like zipping. Okay? Now, these things work nicely together. My advice to you is to accept publishers and return fluxes and monos, things like that, okay? So we've got this repository. What I want to do is I'll write some sample data to the database. I'll say sample data initializer, create an event listener, application ready event, go, and at component. So private final, reservation repository. Now I'm going to inject this into the constructor. I could create a constructor, but I've become quite enamored with required args constructor. Anything that's marked final, it'll create a constructor and a parameter for it. And so what I'm going to do is I'm going to write some data to the database. I'm going to create an array of data. My name is Josh. It's great to meet you. I'm going to add some other Spring team members there to my list. Jürgen, of course. Violetta. Okay, that's 8. I got Dave, of course. We've got Cornelia, of course. We've got Stefan. Oh, wait, no, Arjen. There we go. Good Dutch name. He's Dutch. Lives here. What was I doing? Oh, yeah, Madura. Okay, so there we go. We've got now a reactive stream that we just kind of hard-coded here in memory, kind of. Just names. And I'm going to visit each one of these names. I'm going to turn it into a new reservation. So I'll say new reservation, passing in null for the ID. And that'll give me another stream of reservation objects. Right? So I'm just visiting each one. And now, with that, I want to actually save the data to the database. So I could say map r this.reservation repository. There we are, passing in that. But what happens when I call .save? .save returns a mono of t. And what happens when I call .map? Map accumulates the results of this lambda here into a container type, another stream. So what I actually end up getting is a publisher of publisher of publisher, or publisher of publisher of reservation. Right? So it's a publisher of reservation, which I don't want that. That's one level too many. So instead, you use flat map. Okay? And that gives you just one. It unpacks the intermediate type there. So there we go. Now, there's my saved data. Okay, and turn this into a method reference. Now what happens if I call this code right now, if I run it right now? Sorry?
No subscription.
Thank you. This code is right now a cold stream. Think of it as a pipeline. No data has been, there's a bunch of pipes that have been connected together, but there's no water in the pipes. Nothing is flowing through the pipeline yet. And this is called assembly time. That's very different from runtime. In order to trigger it, in order to activate it, you have to call a terminal function, very similar to the Java 8 Streams API. So saved.subscribe. Now you've seen the most obvious and most famous version of it, the one that takes a subscriber, and I showed you that. But there's also other overloaded versions for everyday use, like consumer, Java 8 consumer. And so I'm going to use a logger here. I'll say @log4j, and I'll log out the results. Log.info, new reservation, and go. Okay, and make that a method reference. Great. Maybe I don't need this. Okay, good. Make that a method reference there. That's not so bad. Collapses down nicely, doesn't it? So there's my cold stream. Now, of course, first of all, I don't want to use all these intermediate variables. I just wanted you to see how these things kind of built one off the other, but I wouldn't normally do that. I'd chain them together like that. And then second of all, this has a problem, doesn't it? If I run this application multiple times over successive runs, I'll see the same data in the database. Right? I'll have duplicate records, which I very much want to avoid. So one way to do that is to delete all the data. I can say this.reservation repository.delete all. Okay. And then I can say find all the data in the database. Right? Or actually, no, I can say let's delete everything. Get rid of that for a second. Let's delete everything. But then I want to write the data to the database. I want this to happen after I've deleted everything in the database. So I'm going to pass in names, okay? And then I'm going to find all the data in the database as well. So here, then many, and here I'm going to say reservation repository find all. And then finally, I'll subscribe and log the results like so. Okay? So what have I done? I've said delete everything first, then write the data to the database, then find all the records, and as the records are arriving, log them out. Now keep in mind, I have a deterministic order here. Right? But there's no guarantee that these are all going to execute on the same thread. You can influence how things are scheduled by providing your own custom scheduler. Right? You don't need to, normally. You shouldn't need to. Right? By default, as long as you're not blocking the threads, then who cares? You're going to just use the default thread, the default scheduler, and that'll have one thread per core, and each thread's an event loop, and that'll be just fine. If you're blocking the thread, if you're blocking a thread though, if you're doing something with a blocking source, like an older database or something like that, then you can only scale out that interaction by adding more threads, in which case you're going to want to create a elastic thread pool, aren't you? So you're not going to use this, you're going to say, I want an elastic scheduler. Okay? So there's that. But remember, that's just going to keep creating new threads as long as they're needed. So you will run into that starvation issue eventually. This should be considered a smell. You shouldn't have to do this. If you are looking for ways to detect whether you've got blocking code, there's a nice project called Blockhound. I don't have it here, but Blockhound is a Java agent. You just add it to the class path and then just call blockhound.install, right before the main method up here, right before Spring application.run. And it'll actually show you where you're sitting on a thread that should be blocking. So we have data in the database. Let's run this code and see what happens, okay? Good stuff. Look at that. It worked. It worked. If we look at this, db.reservation.find, there it is. There we are. All 8 of us. It worked. Of course it worked. It was a demo. What were you expecting? That was always going to work. That's not what I wanted to talk about. What I wanted to talk to you about is this. This is the Spring Boot ASCII artwork. This artwork took a long time to get right. But we on the Spring team have many people who are doctors, PhDs, people who in their previous lives worked in nuclear physics. So it makes me very happy to imagine that someday, somewhere, somehow, there's a GitHub issue that said, darn it, we need good ASCII artwork. And I think you can agree they did a great job. So it's for this reason that I want to take an ever so brief digression to talk about what I consider to be a glaring and serious deficiency in the IntelliJ JetBrains product. For while I'm a fan, I consider this to be particularly short-sighted. Do you see that checkbox? This one? This one right here? This one. That one right there. Do you see it? That one right there? This one? Do you see it? Do you see it? That one. Right there. This one. This checkbox. Do you see that? That one. Right there. That checkbox, once clicked, suppresses the ASCII artwork. What the hell? Why is that there? That's a dumb feature. I don't even know why they added that. Nobody even asked them. The worst thing ever. So I did what all people would do in the same situation. I went on the internet and I cried. And I was given a message of hope from my friend Jan Sabran. This is my friend Jan Sabran. He's a developer advocate at JetBrains. Jan, this is Jan right here. No. Boop. Anyway, he sent me this message of hope, which I want to share with you here today. It's okay, you can applaud. He's my friend, and I trust him. We've known each other for years, and I want to believe him. He says, Josh, relax, Josh. Just chill out, man. Just relax. The release will be fixed in the next installment. Don't worry. It's going to be fine. Don't worry. Just wait for the next release, and your fix will be there. It's going to be okay. And, we've known each other for a long time, and I want to believe him. I want to believe that he's on the level, but I'm just not sure that I'm just not sure that he's on the level anymore. Anyway, let's go take a quick break. Come back in, 5 minutes? 2 minutes? 1 second? 10 minutes. Okay, go. Giddy up. Okay, we're back. So where did we leave off, my friends? Where did we leave off? We left off, we have data in the database, and so far I've been using MongoDB. Show of hands, how many of you using MongoDB? Okay, not 0, like 5, 10, whatever. A number greater than 0, that's really all that matters. Spring Data is the technology I'm using to talk to these different data stores. I'm using NoSQL in this case, or NoSQL, whatever. And these technologies are certainly prolific. I'm not trying to diminish that, but how many of you are using a SQL data store? SQL. All right. I think we can agree that's at least a plurality, if not the majority. And so, while I appreciate that Spring Data supports reactive drivers, these are not reactive facades on top of otherwise blocking technologies. These are actually natively asynchronous drivers, rather, built from the ground up, and they're built on top of these natively asynchronous drivers. So, the Spring Data MongoDB support is separate from the Spring Data reactive MongoDB support. It's a complete re-implementation. Okay, and so as a result, we have a subset of technologies available as reactive drivers. You've got, for example, reactive Cassandra, Couchbase, Redis, and MongoDB in the NoSQL column, whereas the non-reactive regular options vastly outnumber that. There's a good deal many more, like five times more, right? That's okay, right? We're going to see more and more drivers make their way to the reactive world in time, but in the meantime, the options are a little limited. But there's good news for those of us who want to use NoSQL data store. SQL data stores. A common question is, can I do SQL data stores in a reactive application? The answer for a good deal of our time has been kind of disappointing, which is no, you can't really, not really, right? And the reason is because JDBC fundamentally is a blocking and synchronous API, right? SQL data stores don't have to be that way, but JDBC is, right? And this is a bit of a problem because JDBC is what I think most of us think about when we think about SQL data access on the JVM. So we were looking for some way to do non-blocking interactions with a SQL data store on the JVM, and there's talk of an interesting option from Oracle back in 2016. They announced something called ADBA. ADBA was meant to be a asynchronous database API. It's apparently still in development. So, keep holding your breath, I guess. But in the meantime, people are trying to ship software, so we decided to create a spec, a de facto kind of thing, an open source project called R2DBC. It's an open community, open sort of work, and it's got an SPI. It's characterized by an SPI here. And there are a number of different drivers that we've started, PostgreSQL, Microsoft SQL Server, and H2 among them. There's also third-party support for JSync MySQL, right? So this is an R initiative. This is an R2DBC implementation for MySQL, right? R2DBC is early days yet. It's not yet GA. So there's only 4 right now, big ones, but I can tell you all the major ones, all of them except for Oracle, I know are on the way. Right? All the ones you can imagine needing, you're going to have soonish, right? But they're not here yet. Okay, I just keep watching this space. Like I've got, I'm confident about most of the ones that you're likely to ask about, even some that you wouldn't ask about. I think there's one from Google that isn't quite a SQL data store, but it can be used like one for queries. I think that one has one that's coming that's reactive. So, there's a lot of interesting stuff coming, right? But in the meantime, if you're using PostgreSQL or Microsoft SQL Server or MySQL, then you're in luck. How many of you are using one of those 3? I'm just curious. Okay, that's not 0. That's greater than none, right? So that's an interesting option. Now, R2DBC's SPI is a low-level SPI. It's written in terms of the reactive streams types. Our implementations of that SPI, of course, use Reactor. But the SPI itself doesn't prescribe that. It just works in terms of publishers and mono. Sorry, yes?
How stable they are, all of you.
How stable? Well, bear with me here. So I was just about to say, right now, these APIs are fairly stable, and I think you'll see that we're going to release maybe a 0.8 release as a GA thing soon enough. Right? They're not GA yet. The reason we're going to do 0.8 is because it's not yet 100% complete. One of the things that's missing is stored procedures. Okay? Yeah. Stored procedures are notoriously different. They're notoriously finicky. They're notoriously weird across different vendors. Okay. So we wanted to wait until we had enough implementations to see what the common ground for that looked like before we nailed that down. Okay, but everything else I think is in a very good shape. So while it's not yet GA supported, I expect you could see that this year that it'll be GA supported. And I'm going to show you how to use it now. And I've been using it I've done Spring Tip videos on this in my screencast series. I've done videos over the last, I've done blogs and videos and talks for the last year, basically. Since the last Spring 1, I was waiting, I was chomping at the bit to be able to talk about this. We announced it at Spring 1 last year, by which point we had already been working on it for a year, right? So we announced it at Spring 1 last year, and that was when I could already do the basic low-level stuff with R2DBC. Since then, that R2DBC has gotten even better, but since then, we also have Spring Boot integration and Spring Data integration for R2DBC. So again, these are separate, like they're not GA yet, but you can do them now, and that's what I'm going to show you. I'm going to show you how to change this code. Now, keep in mind, this is just a toy of a demo. There's nothing, this is not a real domain model, obviously, right? I'm not trying to show you what an ERD diagram looks like in MongoDB or anything like that. So I am about to make this thing work from MongoDB to SQL, but I don't want you to think that that's a goal or at all. You shouldn't ever go into Spring Data thinking, oh, I'm just going to write something that is so devoid of nuance that it works transparently in Mongo and a SQL data store. That's ridiculous, right? It just happens that this is a trivial toy of an example, okay? So I'm going to go to my desktop here, and because it's new yet, because it's early days yet, there's no starter, there's no checkbox on the Spring Initializer at start.spring.io. So I'm going to add these dependencies the old-fashioned way, the way we used to do it before there were checkboxes. I'm going to use my hands. It's going to hurt, but I'll do it. Here we go. So first things first, paste that in. I need the dependency management section to bring in the experimental. Okay? It may change. I don't think it will much, but it may. And since it is experimental, I want you to regard R2DBC with the same hesitation, the same reluctance, the same fleeting but manifest terror with which you regard PHP. Production, PHP. Never the two shall meet. Never the two shall meet. Okay? One day, you're going to be able to move this into production, but that will never be true of PHP. So, here we are. I've got the R2DBC connection pool. I've got Spring Boot Starter R2DBC experimental, mind you. I've got Spring Boot Starter data, so this is for Spring Data R2DBC, and it's experimental as well. And I've got the R2DBC Postgres implementation. Okay, you would swap this out if you're using H2 or MySQL or Microsoft SQL Server. Okay. Now, I need a URL. So the URL looks like this, r2dbc.postgresql orders. That's my username and password. Shh, don't tell anyone. On this host, and this port, and this database name, okay? In order to get this work, I need to also drop out MongoDB, right? So here we are, good stuff. And I need to define a bean of type connection factory. This is I expect that this will get done for you automatically in due time, but for some reason right now, it just isn't. So it's not a big deal. I can do this. I've been doing all the low-level stuff for so long. I'm just happy to have this in here. So at value, spring.r2dbc.url, string URL. Okay. Good stuff. So there's my connection factory. All right. And that's basically it. So now with that done, I can get rid of this. This is no longer a UUID, right? MongoDB is a distributed data store. It uses a UUID instead of a monotonically incrementing ID. That's a much more natural fit for MongoDB or Cassandra, but it's not a great fit for MySQL data store. So I'm going to change the primary key type here and here. And that actually, that's about it, right? That should get me most of the way home. And let's confirm by going to psql orders, right? Delete from reservation. Deleted, it got nothing. Dereservation. You can see it's got an integer field and a varchar name field. Maps very naturally to our very trivial toy domain, okay? Now, there is a way, by the way, there is a lower level way to use this. You can use the database client, which is sort of like the JDBC template, right? It does for RTDBC what the JDBC template does for JDBC. It's a very lightweight, low-level client instead of this more ORM-y repository approach that's enabled by Spring Data. But either way, are you okay? Sorry? Oh, glass nine. So you can see that worked, right? There's our monotonically incrementing IDs and our names. Let's go to here and select all from reservation, and there we are. Okay? Yes, sir.
Now I see many now they somehow guess. But this what
No, yeah, so okay, good question. The question is, how do I propagate information? And I was going to talk about this later, but let's do it now. You have something called a context. Okay? So ID, whatever, that's just a uuid.random.toString. Okay? This context is visible. It's propagated along the life of the reactive pipeline. Okay? It moves from one thread to another. So if you want to propagate things like a transaction, if you want to propagate things like security credentials, if you want to do MDC, like logging, you can use this. In fact, our distributed tracing framework called Spring Cloud Sleuth uses this as well. So you don't even need to worry about that. If you're trying to do tracing, you just add Spring Cloud Sleuth and a distributed tracing engine like Zipkin, and you're set. It'll automatically flow. It'll automatically follow the reactive thread of execution across multiple threads. Another question that people get, and by the way, you can see that here, do on each signal. I'm going to log out log.info signal.type. I'll log out signal.get context.get or empty ID, right? And I'll log out signal.get the value, which will be null sometimes. Okay? And so we run this. So there you go. You can see what's happening with the context. You can see I've got an optional. So it's get or empty. Get.
I can continue to use context. It will mean different context ID from the same thread.
Yeah. No, from all the, move it across. It doesn't matter which thread, as long as it's associated with the pipeline.
Okay, so different requests, if in the same thread, it will give context.
Yes. Perfect. Okay. Good question. Okay, so now we've got data in the database. We've got RTDBC. A natural next thing is about transaction management, right? Can I do transaction management in the reactive world? And how would you do that? Well, we just answered one question. We can use the context. The next question is, what does the API look like for that? Well, of course, in Spring Framework itself, the low-level Spring Framework, we've always had this thing called Platform Transaction Manager. The API is very simple. You get a transaction, you commit the work, or you roll back the work. Very, very simple, okay? This API has been there for how long? 2003, I think? Right? Yeah, 2003. It works, but it's not natural in the reactive world. So we've just recently debuted a reactive transaction manager, okay? So here's this. And this API, very similar, in fact, almost identical, except that we have these reactive types and the return values. This works for MongoDB and for R2DBC, okay? So you can do Spring Data, MongoDB 4.0 and later supports transactions across discrete documents. Okay, so you can say, I want to write this record and that record, and they're not one is not a sub-document of the other one. They're two separate discrete things. You can do that, and of course R2DBC, which is a SQL database abstraction, supports it as well. So I'll show you how to do that right now. Let's suppose I create a reservation service for some reason, okay? And I want to create an endpoint that creates, let's see, public reservation, save names, string names, okay? And I'm going to create a bunch of names using my repository. So like private final reservation repository at required args constructor, and at service. And all I'm going to do is I'm going to say, for each name, flux.just names, turn each one into a new reservation, null, passing in the name. And then for each one of those, I'm going to flat map and save it into the database using this, like so. And of course, that can become a method reference. Now, I've got a bunch of saves here, but you know what? I've decided for some reason, because I'm a bad person, I'm going to do the validation after I've written the data to the database. So I'm going to say, do on next reservation. And I'm going to do, validate name, r.getName. Okay? So I'm going to create a method here that will throw an exception if this name isn't valid. And what I mean by valid is that the name should start with a uppercase. Okay, so name.char@ 0. If, I guess we can say assert dot is true, name does not equal null, and name.length greater than 0. The name must not be empty. All right, very old trick. And then I'm going to say if character dot is uppercase, first char, assert dot is true, the name must start with an uppercase letter. All right, whatever. Very simple toy example, but you get my point. So I'm now doing validation. And what I want to do is I want to make sure that if this fails for whatever reason, then I roll that back. Okay, I don't want anything that I've written in this block to be written. So I want a transaction. One way to do that is to use a transactional operator like this. This is like the transaction template. So I'm going to inject that here. I need to factory an instance of that object. So I'll say transactional operator. Here we are. And I'll say return transactional operator.create, passing in a reactive transaction manager, RTM. That's awesome. That's an acronym for those of you who don't remember. In order to create the reactive transaction manager, I'm going to use the RTBC implementation, like that. And it's going to take a pointer to my RTBC connection factory. Here we are. Okay? So I've got the transaction manager and the transactional operator and the connection factory. And here, I can say, store that as a variable. Okay? So I'm going to say this dot transactional operator dot execute in a callback, or just wrap it like this. There you go. So now, it's either all going to commit or it's going to all fail. It'll all roll back. So now to try it out, let's go to our initializer and use our newly minted service to see what happens. Okay, so here's this. I'm going to use our service down here. Service, and I'll say this reservation service save names. Alfred. Bob Carter, okay? Dan, okay? That's 4 names saved. Let's see what happens if I run this code, save.subscribe. Okay? So we're going to comment this out for now. So, it'll just be these 4 names. So I'll say this.reservation repository.delete all, then we'll do this. And then we'll subscribe. So I'm actually just writing only those names to the database. I'm going to clean it up and then write those to the database. These all start with capital letters, so we should see 4 records in the database when we start the application. Let's try it. Okay. There's 4. Good. Now, let's do lowercase Dan, okay? Lowercase. So now, nothing in the database. So it deleted everything. And then I tried to write the data to the database, but the transaction rolled back because we threw an exception. All right? And that works even despite the fact that that's reactive. We also get declarative transaction management instead of transactional operator. You can just say enable transaction management, voila, and then just add transactional. In which case you don't need this. What was that? Jeez. Sounds like somebody writing PHP. Screams of the undead. All right, so same behavior, same effect, except I'm using the transactional annotation. Okay? Good stuff. So now we've got transaction management, we've got R2DBC, we've got data in the database. We've spent a lot of time on this. I didn't mean to segue so long into this, but let's talk about building REST APIs, okay? So, at REST controller, this is fairly straightforward. Let's put this up here, I guess, so we have more room to scroll. Okay, so class reservation REST controller. And we're going to inject the reservation repository here. This should look fairly familiar if you've ever used Spring MVC or something like that. Very straightforward, right? I'm going to create a publisher of reservation. And I'll just say return this.reservation repository.find all, and voila. Okay, I'm going to inject that, and I'll start the application. So now, if we go to the browser, localhost reservations, you can see that I've got no data in the database. Fair enough. Let's see, where's my code? Code. Whoopsie daisy. I like this list of names better. Good stuff. Much better. Okay. Okay, so there's my data in the database, all right? So now I've got data, I've got a simple REST API. This is not particularly new, right? This is not controversial. You've seen Spring MVC before. I'm sure that this doesn't look particularly novel to you. But keep in mind, this isn't Spring MVC. This is a brand new reactive web runtime. Even though the annotations are the same, there is no servlet API here. We're built on top of Netty from the ground up by default. This is a brand new reactive web runtime built on the ground up from Netty, okay? So, and where reactive APIs come into their own, keep in mind the framework is going to subscribe to that publisher. So this is a cold publisher. There's no data in this publisher yet. This is an IOU. You are giving the web runtime a thing saying, here, hold on to this. It's worth real data. It's not real data right now. You need to subscribe though. So the actual processing, the actual network calls, the actual processing of the data doesn't happen until something, the framework, calls subscribe on this thing. And that happens in a separate thread. So again, keep in mind what that means for thread locals. You can't use them here, right? But you can use context. You can use the subscriber context that we looked at before. All right, so this is fairly natural, right? I like this style. But consider all I'm trying to do is to create an HTTP GET endpoint that returns data for /reservations. And this is the data. I've got a class, I've got two annotations, I've got a constructor, I've got a method, I've got annotations, I've got storage for a field. I've got a whole bunch of stuff that is separate and apart from what I'm trying to do. And if we're building a Java 8, then we have, as part of our baseline, lambdas. And so this has enabled a new API, a new functional reactive API, like this. Routes, return, route. Build, okay, .get /reservations, new handler function. All right? So there's my handler function. And what I'm going to do is I'm going to inject my reservation repository. I'll say return a server response .ok.body rr.findAll. And the data that I'm sending back is of type reservation. Now this is a lambda. You can see the ID is trying to help me out with that. It can be made cleaner with static imports. And there is my rebuilt, reworded functional reactive endpoint. It's just a builder method, so I can chain these together. I can say post, blah, and pass in a handler there, of course, and another one there, and so on. So you can keep all the routing in one place. Now this is a little tedious, a little verbose. I mean, it's not as verbose as before, but still, it's a lambda. It would get, if you had business logic, serious business logic, this would get kind of ugly. So a very useful pattern here is to create a separate object and then use method references, which Java 8 supports, right? You can use method references to tell this method, hey, invoke this method on this other object later on, okay? Either way, let's restart this application. Okay, same data, same endpoint, same everything. I just commented out the REST controller. Okay, now, this isn't a big deal, is it? I don't think any of us are impressed with, oh, look, you've got this brand new reactive web runtime, but I can serve 8 records of JSON data. Who cares, right? I could do that with synchronous blocking servlet-based APIs as well. That's not a big deal. Where reactive APIs really come into their own is for long-lived transactions, long-lived connections, things that would otherwise block a thread. So let's consider one of the most famous examples of this, WebSockets, okay? So let's suppose I have an endpoint here called greetings, or I have a service rather, called greetings service. And greetings service produces a never-ending stream of greetings objects, class greeting requests. Okay? And each request has a name with it. Name at data at all-args constructor at no-args constructor. And I get back a stream of greetings responses. Like this message. Okay? Good. So now I'm going to stream a never-ending stream of greeting responses whenever I'm asked for these greetings. I'll pass in a greetings request and get the response back. And so I'm going to use the scheduler, which we've talked about a number of times already, to generate a never-ending stream of data using a supplier. So it'll be a new greetings response. Hello, request.getName at instant.now. Okay? Now this is a Lambda. Very nice one. Good. And I want to stagger the rate of production. I don't want to produce a new I don't want to have my console fall off the side of the screen or the end of the screen. So I'll stagger the rate of production by using a delay. Okay? So there's my service. Now, I want to turn this into a WebSocket endpoint. It's going to be a never-ending stream of greetings. I'm going to send a WebSocket request saying, hey, here's my name. And it's going to send me back a bunch of greetings every second saying, hi, Josh, at 1 second. Hi, Josh, 2 seconds. Hi, Josh, 3 seconds. Whatever. Okay? It's a trivial example, but it works. So here's the WebSocket code. Class, WebSocket configuration at bean. And it'll be a WebSocket handler adapter. Okay? And we'll need a bean for a WebSocket handler itself. That's our business logic. We're going to come back to this in a second. To do. And we need a simple URL handler mapping. Okay? And this is the thing that mounts our endpoint, our handler, to the HTTP users. Okay? So I'm going to inject the WebSocket handler, the reference, the collaborating object here. It'll be called WebSocket handler, WSH, and the order will, of course, be 10, because why not? So now, let's look at our business logic here, the actual thing that matters. The WebSocket handler is a very simple callback interface. It's a Lambda interface, of course. But here's what it looks like. When the WebSocket client connects to the web server, a new WebSocket session is established. And you can store that reference and do with it whatever you want, okay? You can pump data into the session. You can send data into the session, and that'll get delivered to the client in the browser or whatever. You can use Java to consume WebSockets as well, for example. So here's what that looks like. I'm going to say session.receive, and that's going to give me a publisher of WebSocket message. Each one of those, I'm going to map from WebSocket message to the text in the message. Okay? That gives me a publisher of names. I'm only going to get one after all, but it's being given to us as a publisher, a flux of names. Each name, I'm going to turn into a greeting, right? In order to do that, I'm going to inject my greetings service, the thing we just created. Okay? So we're going to say name for each name, service.greet, new greetings request, passing in the name. So that gives me a publisher of publisher, which I don't want. So we talked about flat map. Okay? Good stuff. Greetings. Okay? And for each one of those, I'll say, hey, let's turn that into a WebSocket message that I can send on the client. So I'll say gr.getMessage. And for each one of those, I'll say map text into a session.textMessage. Session.textMessage, passing in the text. And voila, okay? I'm going to send that whole WebSocket message publisher on the session, like so. Okay, WebSocket message flux, and there we are. Now, of course, would I have all these intermediate variables if it was just me? Of course not, right? I just string it all together. It's easy to read, at least for me. I don't know. Your mileage may vary, or your kilometers may vary. Okay. Good stuff. So receive, good, WebSocket, chat, whatever. Okay. And there's my business logic. There's the whole thing. So I receive the data, turn it into text, turn that text into a bunch of greetings, get the response text from the greetings, turn those into text messages, send them back to the client. Okay? Now, in order to demonstrate this, I need to do something that I'm not proud of, something that I didn't want to do, but I feel like I have to do it just for ease of edification, something that I wouldn't have otherwise done in polite company, but here we are, okay? I'm going to write JavaScript. Okay. Body script window.add event listener load function, and I'm going to say var ws equals new WebSocket ws localhost 8080 ws.add event listener open. So when the WebSocket first connects, the open callback gets called, and I can send a request to the WebSocket. That's what I'm going to do here. The request is going to be a name, right? Which name? Well, I'm going to ask the user when they load the page, who we calling? Okay. I'll send that here. I'll say name. And that's going to result in a bunch of responses coming back from the web server. So I'll say on new message, log out the data. Message. Okay. New greeting. Message.data. Good stuff. Okay, now let's restart. I'll take some coffee. Okay. Localhost ws.html. Row. Did I do that wrong? Source main resources static. Oh, thank you. WS. Thank you. Okay, who are we greeting? Tammy. All right. Okay. So it's a reactive stream of WebSockets. Now, in between each raindrop, in between each message, that thread is not kept open. Somebody else can use it. Somebody else can do something with it. I'm not blocking that thread. Okay? This allows me to handle more users in between. The scheduler is moving work on and off. Okay, so that's a server. That's a very basic server. We could have done server-sent events and all that stuff, but what I really want to focus on now is what it looks like to be a client of this service, such as it is. It's kind of a service/web page thing. It's whatever. It still has an API, okay? So let's now turn back to my second favorite place on the internet, start.spring.io, and build a client. And in order to build a client, we're going to use the right version of Java, which is anything after 8, especially after 11. And we're going to use reactive web support. We're going to use Lombok. And we're going to use RSocket. And how are we doing on time? Ooh, I guess that's about it. We'll just keep it short. Do you want to see gateway? Do you want to see a reactive API gateway? Who doesn't want to see a reactive API gateway? A little bit? I'll show you a little bit. I have to. It's so cool. Okay, hit generate. And now, downloads. Oh, here we are. We're already there. Good. UAO. Whoops. RM, RF, zip. Okay. Let me make this called client. UAO. What the? All right, client. So now we're going to build an API edge service. It's a first port of call for requests coming in from the outside world. It's the first request that comes into the system from things like edge services, and it's a thing from actual clients like your PlayStation, your iPhone, your Android device, your Xbox, etc. Whoa, that freaked me out. It's the first port of call for requests that come in from the outside world that you want to adapt to your downstream services. So rather than forcing every single downstream microservice to accommodate any incoming request, instead you would normalize them at this edge service. That's a great place to handle cross-cutting concerns as well. Things like security, routing, tracing, etc. And so we're going to create an edge service. Here's our edge service. We've opened it up, I think. There we go. And this edge service is going to run on a separate port. I'm going to run on port 9090. And the edge service is, you can do a lot of different things here. One thing you can do is in an edge service is a API gateway. And in order to support that, we have a new project called Spring Cloud Gateway, which builds on top of the reactive runtime. Okay? So we can say routes are spec, and we're going to come back to that in a second. And what you do is you build a bunch of routes like this, right? And you can chain them together. And each route has a few key ingredients, the first of which is a predicate. How do you want to match incoming requests? Right? So I'm going to say anything that comes into this vhost foo.bar, asterisk.foo.bar, and has this path is going to get matched. And when they get matched, I want to send it somewhere. I'm going to send it to, let's say, localhost 8080. Okay? But of course, localhost 8080 doesn't have anything on it, so I want to send it to reservations. But remember, it's a proxy, right? It's going to act as a proxy. So this request is going to the path called /proxy. And so it's going to send that request unadulterated to this URL. So what it's going to try and do is send it to localhost 8080 /reservations /proxy, or something like that. So we need to tell it, no, I want to change the existing path, and you do that with a filter. Okay, fspec dot set path reservations. And once you're in the filter array, you can do all sorts of other interesting things here. You can, for example, prescribe retries. You can say, I want to do a redirect, right? And give it a URL and a status code. You can also do rate limiting, right? You can do all sorts of interesting things. Maybe you just want to add a header, like for cores, for example. So HTTP headers.access control.origin, etc. Okay, pretty simple. Let's see what that looks like. Okay, what? Go away. Okay, localhost curl -h spring.foo.bar host, and it'll be localhost 8080 /proxy. Okay, thank you. 9090. There we go. There's my JSON. So I'm actually routing it, but if I look at -v, the output, the verbose output, it says that the header has been added. Now I can do cross-origin request scripting from one JavaScript client to another on a different host and port, right? I've added that. Even if my downstream services don't support that, the proxy is what they connect to, and now they can do it. So this is one thing you can do, and there's nothing super reactive-y about it, but it works because it's reactive. Behind the scenes, there's a lot of stuff that's reactive here. Okay, a lot of times, though, this is not what you want. A lot of times, instead of sending a request completely unadulterated directly down to the downstream thing, you want to translate it or transform it in some way. This is more, not as much an API gateway and more an API adapter. API adapters have awareness of the semantics of the payload being sent, and they operate on that payload in some way. So let's suppose I created a new endpoint here, a new functional reactive endpoint that just showed me the names, right? I'm gonna have a call to my downstream service that returns only the reservation names. So it's not just the reservations, but the names. And in order for this to work, I need to create a functional reactive endpoint, and I need to call into some sort of reservation client. So I'm going to create a reservation client, like so, and it'll return a publisher of reservations. Get all reservations. And in order to do its work, I need this type. I need this DTO. So I'm going to do something terrible, something that you should never ever do, ever. Not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So here we are. Paste. There's this. And there's my DTO. Add component. Goody. And in that, I'm going to use the reactive HTTP client called Web Client. This is a non-blocking client. It's like REST template, but on the client side, but for reactive, right? So I'll use this actually. In order for me to get a web client, I need to vend or factory or produce an instance of that bean somewhere, and that's pretty trivial. You just say web client, inject the web client builder, and just say builder.build. Okay, so there you go. There's my web client, and now I'm going to make a call. I'm going to say return this.client.get.uri HTTP localhost 8080/reservations. And when the data comes back, I want to turn it into a publisher of reservations, like so. Okay. Now I can use this client here in my new name endpoint. So here we are. We're going to inject the reservation client as a collaborating object here. Reservation client, RC. And I'll say rc.getAllReservations.map r.getName. Okay. There's my name. Okay, my reactive stream of names, my reactive stream of different string names, and I can send that back here as names like this, string.class. That's kind of cool, right? But tell me something. I've just made a network call over the internet. Is that a good idea? Is that always going to work? Can I trust my network to always be there, to always be infinitely fast? Right, totally, yeah. I can't even trust Wi-Fi to be infinitely fast on my own network in the same room as the repeater, right? I definitely can't trust the open internet. So this is a terrible idea, right? If you knew the sheer probability of a network connection actually working, it would just keep you in bed. You wouldn't even bother. It's just so depressing. So the fact that this does work and it works often is it's just a staggering miracle, okay? But it shouldn't. Nothing to tell. I'm not convinced planes should be flying, and I'm not convinced networks are real. So this information, this call is going to fail. Maybe not now, maybe not next week, but it will fail at some point. It's a fact. Statistically, it will fail. As your system scales sufficiently, something will break, right? So I need to build a little bit more intelligence into how I deal with those errors. With Reactor, that's easy to do. I can actually say, oh, I want to retry. Retry 10 times. Or, more intelligently, retry, but back off. So like, take 1 extra second the first time, take 2 extra seconds the second time, and so on until the 10th time, in which case you'll take 10 seconds, right? So I'm giving myself time to heal. I can do on error resume. If something goes wrong, I pass in this handler. I say flux.just eek, right? So if something goes wrong, an exception is thrown, I catch the exception, I get to deal with it here, and I return a default, a failure mode version of the data. Let's comment that out because I don't want to retry for 10 seconds just to show this to you. Let's see this. Good. So there's my names. Okay, now let's see what that looks like. Okay, so curl localhost 9090/reservations/names. Good, that works okay. There's our data. Now we're gonna go over here and do something kind of scary. Do you celebrate Halloween here? No. It's a day where you're supposed to scare yourself. Little children. It's a day when like you celebrate scary things, kind of. So little children run around as EJBs in the neighborhood, dressed as EJBs, scaring the daylights out of other people. Okay. So I am going to show you something kind of scary here as well. Ready? Don't blink or you'll miss it. Boo. Okay. Anyway, that's gone. And this is even scarier. A dead service makes my heart stop. It's very scary. So I don't like this at all. But, whoops, wrong one. Okay. So I called the edge service. It tried to call the other one. It threw an exception. And instead of getting a 500 error stack trace, I degraded gracefully. I used the operators to introduce robustness into the way I handled the error situation. Okay. Now, I like this approach, but this is kind of dumb, right? This is dumb in the sense that it's just going to do work all the time for no reason. There's no way to tell it, hey, don't worry about it. Don't bother. It won't work. Don't worry about it. It's not gonna work this time. Just don't bother, right? It's just going to naively attempt to do the same thing over and over and over again. So, cat desktop misc spring cloud, whoops, deps spring cloud. Come on. Nope. Circuit. There you go. We have a new project here called Spring Cloud Circuit Breaker. Okay. This is an abstraction. You can use it with Netflix Hystrix. You can use it with Alibaba Sentinel, resilience for J, and Spring Retry. Okay, and it supports reactive APIs as well. I'm going to use the resilience for J version of the circuit breaker, and I'm going to inject a circuit breaker factory. So private final circuit breaker factory. And of course, at this point, I better have a constructor, like an actual constructor, because you need to initialize all that. Whew. Okay? And what I'm going to do is I'm going to actually create a circuit based on the circuit breaker factory. So circuit breaker, it'll be this dot circuit breaker equals circuit breaker factory dot create name. So I'm going to stash the reference to the expensive to initialize circuit breaker. And now, what I'm going to do is I'm going to use the circuit breaker to guarantee that when this fails, I have a fallback behavior. So here's my publisher. Okay. Oh, I need a reactive circuit breaker. And did I inject the wrong one? I did. Reactive circuit breaker factory. There you go. So now I can say this dot circuit breaker dot run here. Okay. Now I want to also provide a fallback value. So this is very similar to what we looked at before. Here I'm going to say just return eq. Now why do this instead of what I had before? Well, whoops, which is this? What did I just do wrong? Save names. Are we in the service side? I'm in the wrong project. How awkward is that? Awkward. Don't worry. It's okay. So, that is awkward though. Somebody could have told me. It would have been fine. All right, whatever. Okay, so back over here. Paste this in. Okay. On the code side, I'm going to inject a circuit breaker factory. I guess I could do it here. Private final circuit breaker, reactive circuit breaker. And I'm going to initialize that in the constructor. And so it'll be reactive circuit breaker factory, factory.create names. There you go. And I'm going to use that reactive circuit breaker in the code for my call to the potentially shaky, potentially error-prone thing. So here. So I'll say this dot circuit breaker dot run, and when something goes wrong, when I have an exception, let's just return this fallback value. Okay, there you go, much better. So the reason that this is different from what I showed you before is because this circuit breaker creates a registry. There's actually a thing in my code somewhere that other threads can look up and introspect. They can ask the registry, hey, is data able to flow through this circuit? Is data able to pass through here unhindered? If so, we say that the circuit is closed, right? If there is a problem of some sort that has forced the circuit open, the data won't go through that circuit. It's open, and so the circuit isn't connecting. Nothing is being conducted. The nice thing about this is that we can use some really smart heuristics to come along and say, hey, I detected that there are no services of the type that you're trying to call in the service registry, and you're gonna try and resolve this URL via a service registry maybe. What's the point if there's no service downstream to which to route it? And so instead of trying to make the call and then getting an exception and then falling back, I could just go to the fallback behavior directly until something comes along separately in another thread, and a side thread then closes the circuit again, right? So you get the same basic behavior, it's just that now you've got this smart. You can actually do some very, very smart things based on that ability, okay? So let's try that again. There's the client, good. Okay, same as before, but now go to the service. Boo. And we get eq again, all right? Now, these are some ways to make your clients and your services smarter. This is really, I mean, one of the really interesting possibilities here is what we can do because we've deferred the assembly time, we've deferred execution time from assembly time. They're not the same thing. My construction of the pipeline is not the same thing as the actual execution of the pipeline. So I can do some very interesting things here. Let's say I want to take a stream. I want to get all the data from this thing over here and all the data from this thing over here. One service over here, another service over there. I want to combine the results and then stream them together. What does that look like? Well, Suppose I have a publisher of strings, whatever, names, to do from one service. Items, I don't know. And then a publisher of prices from another service, okay? To do, right? And they're related somehow. I don't know how you got at them, but let's just say you want to join them now. Well, that's easy. Say items, prices. And now you get a tuple. You say tuple dot get T1 and T2. It's going to take stream 1, take one from the left side, stream 2, take one from the right side, stream 1, left side, stream 2. It's like a zipper, right? It's going back and interlocking things. It's zipping down the zipper, and it's emitting a new item for everything as they arrive on both sides. Pretty natural, right? Now, of course, I just used 2 items here, but in perpetuity, in truth, you can actually do a good deal many more, right? You can actually provide a variadic array as well. So that's just a very natural thing to do. Another thing that's very natural to do in a reactive application is something called hedging. Hedging, do you know that word in English? Hedging means, like when you go to a casino or something like that, you don't put all your money on one bet, right? You want to make sure that you diversify the risk. You spread the risk so that even if this bet loses, this other one might win, okay? So you say that you've hedged your bet. This bet might be bad, but I'm not going to lose everything. I've hedged my bet. I have this other possibility as well, right? Same thing in the stock market. You don't put all your money in the same stock, because that company might go out of business, and then what? You're in trouble, right? So you keep your money in a lot of different stocks. You hedge your bet. Same thing for high-performing organizations. If you're a high-performing organization, you want to make sure that you don't deal with SLAs incorrectly, right? Oh, I had to sit down. My legs were numb. If you're in a high-performing organization, you want to make sure that you deal with SLAs correctly. So imagine you're a high-performing website, and you have clients that are coming to your edge service, and they are expecting that you will give them a response within, whatever, 100 milliseconds, okay? And then that edge service now in turn has to make calls to other services, which then makes calls to other services. Something in the chain fails. Now what? You're in trouble, right? Because your client is now dependent on that SLA having been met, and it's not going to happen, right? That service, for whatever reason, is out to lunch. It left you an IOU letter, right? It says, here, this is good for one result, come back later, right? What are you going to do? It's not acceptable, right? It's taking a nap. Maybe it's garbage collecting, maybe it's down, maybe it's on fire. Who knows? The point is, you're in trouble. So high-performing organizations don't settle for that. They use hedging. They call the same service deployed identically across different nodes, right? And then they call the same service 2 or 3 times. The first one that starts to stream values back to the client, they keep that result stream and discard the other ones. They apply back pressure to the other ones. That tells the other ones that are slower to don't bother. Just go ahead and cancel the pipeline and don't bother streaming any more data. I don't want to waste your time. I've already got enough data, and I've taken the fastest one, okay? Well, what I'm trying to do here is, it's by definition a race condition. The success in this case is a race condition, right? I'm trying to create a race condition. I want the race condition. This is not code you want to write by yourself, right? None of this code that I've showed you today is code that you want to write by yourself, using phasers and semaphores and countdown latches and cyclic barriers and threads and executors and executor services and runnables and so on. So with Reactor, these things are very easy to express. Imagine I say, flux of string host one. Well, actually, look at this API here. Get all reservations, right? Here, I've got this method. Let's parameterize it, okay? So I'm going to say string host private. Sorry? 10, 15 minutes? It'll be okay. Are you going to revolt if we go another 15 minutes? Is anybody going to die? It's okay? Okay. Like, I came from San Francisco for you. No guilt, no pressure or anything. I'm not saying I would feel bad or anything. It's my dream. But, okay, so I've got a method that is now parameterized, okay? Get all reservations, host 1, okay? So by the way, where would I get those hosts? You can't use DNS for this, right? You'd have to use a service registry. You need to be able to ask something like a service registry. Console, Zookeeper, etcd, Cloud Foundry, Kubernetes, whatever. All of them have service registries that you can use to ask, hey, given this service ID, this logical service ID, give me all the different hosts and ports on which that service can be found. And I want distinct hosts and ports, okay? So you can use that with a Spring Cloud Discovery client like this. Whatever, assuming you've configured it and injected it, then you can say discovery client.get instances foo-service, and that would give you a bunch of service instances, and you can just take 2 or 3 of them and use them to get 3 different distinct hosts. So let's say now I've got 3 different distinct hosts and ports, right? 3, 2, okay? Now remember, I'm making the network call, I'm defining the network call, but I'm not actually making the network call. I've defined the assembly of these network pipelines, but nothing's happened yet, right? And now what I want to do is I want to say, okay, let's launch all 3 of them exactly at the same time. Whichever one starts streaming values back for me first, I'll take that one. How hard do you think that code is? Yeah. Flux.first. Okay. How cool is that? So not only does it give you the first one that responds first, so the result of this is a publisher of reservations. It's going to do it's going to give us the fastest one, whatever that one is, and it'll apply back pressure to the other ones. And I use 3 here, but it could have been 2, it could have been 5, it could be whatever. It doesn't have to be 1 host or 5, it could be any number. It's just a very natural way to think about building systems. Service orchestration and composition is a very natural outgrowth of reactive APIs. And there's actually a really nice project here that I quite like called Assembler. Assembler is a third-party project, nothing to do with us, but I think it's quite interesting. They have a version of this API built on Reactor, and you can use it to solve the one-to-many sort of service, n+1 service orchestration problem, right? So here you say, hey, I've got a logical transaction. This is my my domain entity, right? A transaction. It could be an order, a line item, whatever. And you can say, I want to define the assembly of this data using these reactive calls. And then I want you, and it gives you these nice rules. You can say, hey, create an assembler of this thing with the ID extractor called this, and then using that, correlate that with these calls here, right? And then assemble that using this constructor, this factory method called transaction.new. It's very natural to now do scatter gather kinds of orchestration calls in your architecture. Very, very natural use case. Okay, so I quite like all of this. I think there's a lot of potential here. And I'm going to go ahead and say something kind of controversial. You know me, I'm very modest. I wouldn't say anything controversial, but I am going to go ahead and say it anyway. I think that HTTP has a future. Now I know that seems a little forward thinking, a little controversial. I know that the jury is not yet out here, but I think HTTP, it's going to be around for a while. Okay, but I don't think it's a particularly great application protocol. Okay, I think it's a very good document retrieval protocol. Okay, and what I mean by that is it's great for the use cases for which it was designed. It serves its purpose perfectly. But it doesn't seem to me as though it was designed for applications, modern applications. And so a lot of different organizations have come to that same confrontational sort of, result, okay? Think about it. How do I do request response with HTTP? Natural, very easy. I say, get me this URL, and it gives me a response. Okay, no big deal. What about if I want to send a request and I want to get a stream of results back? How do I do that? Well, WebSocket, sure. Or server-side events. Server-side events is a content type. Great. Okay, so let's talk about WebSockets. How do I do security with WebSockets? What? There's no headers in WebSockets. There's no way to propagate a token, right? There's no way to do that. It's what? That's the certificate, but that doesn't mean I know who's making the request. I have no context. Yeah, certificates are not security, right? That's just part of it. So, I don't know. It just seems like they didn't think about it, which is a bit of a bummer because they really should have, right? What about server-side events? Server-side events are part of HTTP. They're not a separate protocol, right? Lots of things. We'll talk about that later. Actually, we won't talk about it. We'll talk about it a little bit. It's a good first step. Server-side events are another thing. They're HTTP, and they also work with HTTP 2. They support binary data, right? That's kind of nice. They require HTTPS. They don't require, but in practice, that's what you're going to use. So that's a lot better, right? But still, what about server-side events? How do I do interesting things with that? Remember, server-side events by default are text. So even though it's being transported as binary, you have to produce text, and then that gets converted to binary. The client gets it and turns it into text, only to realize that the payload of the server-side event is text. It's base64 encoded text. You have to unbase64 encode it to get the binary data. So you don't really want to use that for transporting binary data. It's fairly inefficient. Okay, well, okay, so, but at least we have an answer. I can do one request in, multiple responses back. What about server sends me a request to the client first? What about server-initiated communication? Right? Gets weird. Okay, now what about fire and forget? How do I send a request in and get nothing back? Not even an acknowledgement. I don't want anything. I want to send something and then move on. For things that I don't care about the response, like logs, that kind of thing. This is a very useful optimization at high-scale systems. So there's just all these little use cases. Another thing is, what about the speed of HTTP? HTTP itself is very porous, right? It's a very porous sort of protocol, even with HTTP 2. And another problem with HTTP in general is that if you want to use it, you create a lot of connections, right? HTTP 2 fixes some of this with pipelining for things like assets and images and so on. But you're still, in general, the model is you create a new request and you get a new response. If I want to do fast communication with something, I want to keep a multiplexed connection open. I have a stateful, multiplexed, bidirectional communication socket. So we can use gRPC, which built on top of HTTP 2. gRPC is a nice option. It's asynchronous, okay, but it's not reactive. So Salesforce, they're a small company. Do you have Salesforce here? Salesforce? Anybody know of Salesforce? No? I never know what other parts of the world know. It's weird to me. For many years, nobody knew what Netflix was. I was like, oh, okay, well, it'll come. Okay, Salesforce is a CRM, okay, customer relationship management software. Salesforce, they're big. They're like a lot of traffic. They use gRPC, but they wanted to use it with reactive APIs. So they created a compiler plugin for gRPC called Protalk. gRPC compiler is called Protalk. And what gRPC does is it requires you to create a service definition, and it transpiles that service definition into Java code. The resulting Java code is not reactive. So Salesforce created a plugin for Protalk that generates reactor-based services for gRPC. Okay? Pretty cool. Not bad. But gRPC requires everything be Google protocol buffs. So bad. Not good. Right? We're back to where we started. So Facebook, they're a small company. Do you have Facebook? Do you have Facebook? No? Okay, I don't use it either. It's fine. But as far as I understand it, they're the idea behind Facebook is so that you can spam your friends, your family, and your loved ones mercilessly and endlessly until such time as they hate you. And that's the goal, right? I'm not sure what people use it for, but I think that's the idea. And Facebook, they have the same quandary. They're trying to solve this sort of high-speed intra-service communication problem as Google was trying to solve. But they saw limitations in gRPC, and so they decided, well, okay, what if we created our own binary protocol, our own protocol on the wire that was natively reactive? Oh, by the way, did I mention that a lot of the people that are building this protocol came from Netflix? These are people from Netflix that had worked on RxJava, that had worked on Hystrix, and worked on all these sort of Netflix OSS projects. These people came to Facebook and they said, how can we build apps that are natively reactive and make this as general purpose as possible? So it can't just be Java middleware, it has to be a protocol, a native protocol that is reactive on the wire. So they created something called RSocket. RSocket is a wire protocol. It's built for reactive users. It's got the idea of back pressure communicated on the wire itself. It's a multiplex connection, and it supports 4 different kinds of message exchange patterns. Value or multiple values in, 0 value out, 1 value out, or multiple values out, a stream out. So you can have a stream in, stream out. You can have 1 value in, 1 value out. You can have 1 value in and a stream out. You can have a stream in and 1 value out. You can have 1 value in and no value out, a stream in and no value out. You know, all these different kinds of message exchange patterns. So it's not really client-server anymore. It's node to node. Okay. RSocket is payload agnostic. It's binary by default, but it doesn't care whether you're using Google Protocol Bus or Message Pack or Avro or Thrift or JSON or whatever you want. It doesn't care. It has headers because it's 2019. Of course, it has headers, right? It has a built-in frame in the protocol itself for communicating information about the state of the service. Was it somebody here that asked me earlier about what happens if the service is overwhelmed? So we talked about back pressure. The client uses back pressure to tell the server, please stop, I'm overwhelmed, I can't handle any more data. But how does the server say to the client, hey, I can't handle your request right now, I'm busy. I've got way too much capacity, way too much work. How many of you know about the actuator, Spring Boot actuator? Actuator is a set of HTTP endpoints that Spring Boot provides that surfaces information about your application. Things like its uptime, its health, the state of its different transitive dependencies, like its data sources and file systems and connections and so on. Actuator is a kind of an agreed upon arrangement between us, the developers, and our infrastructure. It's a way of communicating the state, the health of a given service. And if you're smart, you can use that for some smart kind of load balancing decisions and reliability decisions. But not everybody's using Spring Boot. And not everybody knows exactly what the format of the actuator endpoints look like. Hopefully you do. But even that changes from one version of Spring Boot to another. I would say that of the billions and trillions of pages on the internet, most of them are probably not using actuator. Right? Just a thought. So it's a bit of a bummer, a bit of a missed opportunity here. That information should really be there. There should be some default way to ask a service, what's your health? What's your uptime? If I make this request to you, am I going to have to wait a week? Or will I get a response? Right? So RSocket has a frame in the protocol explicitly for this. A client, or one node can ask the other, what's your uptime? What's your status? And it's arbitrary. It doesn't have to be actual uptime. It could be, how many users are connected right now? How long is your mean time to response for a given request, right? You can communicate whatever you think would be meaningful to a client of yours. So RSocket is a very, very interesting protocol developed by Facebook. It's a native protocol. There are a number of different clients developed in Java, in C++, and in JavaScript, right? And there's more coming. So I think there's one coming for that as well. The community is burgeoning. So Facebook itself developed only 3, but there's a bunch coming out already. So there's the Java client. When they built the Java client, this team at Facebook, a lot of whom came from Netflix, a lot of whom worked with and worked on things like RxJava, when this team built a Java client for RSocket, well, it was only natural, given that they had this experience with RxJava at Netflix, where RxJava was created, it was only natural that the Java client that this team at Facebook built would use Pivotal Reactor instead of RxJava. Wait, what? Yeah, now I don't know why that happened. I just like to think it's because we're awesome. Whatever. Either way, the Reactor, the client that Facebook uses in Java, the Facebook client that they built in Java, uses Reactor. So it's a cinch to plug in if you want to use the raw RSocket API. But it is a little low level, and it's lacking in a few things. It's missing a few things. Out of the box, it is just a connection. It's a socket. Client connects to another, one node connects to another, and they establish a connection, and you can send whatever you want to the other socket, but what you do with the message, once it's there, it's kind of up to you. You can have a switch statement saying, hey, if this message looks like this, send it over here, but basically there's no concept of routing. So we worked with the team there, and we've added this concept of routing to it, right? We premiered it, we were debuting it in Spring Framework 5.2. That's the new release of Spring Framework. And we've been using that all night. So I can actually use RSocket. That's what I'm going to do here. Let's briefly do one more trick. One more thing. Let's create an RSocket service for our greetings endpoint. Okay? So, class, greetings, RSocket controller. Oh, did I also mention that we've created a programming model so that it looks and feels just like any other Spring endpoint here. So greetings, a publisher of greetings response with a greetings request coming in. And I'm going to use the greetings service. Yep. Yep, just sure, 5 minutes, yep, or less. Yeah. Don't worry. I want to be very good. So, this .greetings service .greet request. Okay, there's my RSocket server. And, whoops. RSocket server port is going to be 7070. Okay. And that's it. Okay. Now you can do a lot more, but I'll leave the details for that for later. But this is the thing that we've created. This is the routing. This is how you can say when somebody connects to the socket and they connect to this endpoint, call this handler. Now on the client side, I'm going to create an RSocket greetings client class, greetings client, and I'm going to use a private final RSocket requester, and the requester is the thing that we use to make the endpoint call. So I'm going to say public flux of greetings response. Oh, I need to do more copying and pasting. Look away. It's horrific. Greetings, request, and response. Good stuff. Here we are. Greetings responses. Greet given a greetings request. Okay. Requester dot route. I'm going to send it to the greetings endpoint. And we're going to go to the other service, but we'll talk about how that connection is made soon. And here's my greetings response. Good. And now, in order for this to work, I need to inject. I need to vend or fabricate an instance of the RSocket requester. I can do that here. Okay. RSocket requester. RSocket requester dot builder dot build. Return builder dot connect TCP. TCP client transport. What is that? Connect. There you go. TCP client. Actually, that's interesting, isn't it? Connect TCP. And that's just what is that? TCP. Yeah, it's a host and port. It's a local host. That's new. 7070. And then I need to get the reference. I block it. There you go. Now, I need an RSocket. I need a client. I need to create the edge service, the HTTP edge service, so that we can see that this is working. So I'm going to use servers and events. Greetings, name, new handler function, and I'm going to inject my greetings client here. gc.greet var name equals request dot path variable name var request equals new greetings request, passing that, passing this to this. That's my greetings responses. And I'm going to send a response. I'll say server response dot okay dot content type, and the content type is servers and events, and the body is responses. Greetings response dot class. Okay, so that's going to start up. I'm going to say greetings / name. We'll get a service and event stream of data. And that stream is going to, in turn, be data that's going to be sent across the wire by RSocket to the other server. So, hello, WAES. Okay? So now we're using HTTP. We're streaming data from an RSocket connection across the wire and adapting it to service and events. It's all right. Good stuff. Now, my friends, we've only just begun to scratch the surface. Obviously, there's a lot of possibilities here. Because RSocket is a stateful multiplex connection, you can do some very interesting things. Imagine using Spring Cloud Gateway, which I just showed you. It speaks RSocket. It's speaking RSocket. It's going to learn to speak RSocket. That's another possibility. Imagine you've got 10 different microservices. All of them have completely blacklisted firewalls. There's no ingress at all. There's no way to get to these microservices. They all spin up. They open up a connection to the gateway, and that connection is kept open. Remember, one of the reasons that connections with microservices are so slow is because you have to do the open, you have to create a connection, do the ACK, and so on. But if you keep the connection open and you're just always open, it's super fast to send data across the wire, right? So with RSocket, you can do that. Now, when this client connects to the gateway, and something comes to the gateway and says, hey, I need the service, the gateway knows which RSocket connection to send the request to, and it sends it down there. It's a natively reactive API though, so if something goes wrong, it can automatically resume and move over to the other node. It can cancel this one and pick off where it left it off on another node. You can't do that with HTTP. With HTTP, you can cancel, and that's it. There's no way to do session resumption. There's some amazing possibilities with RSocket, and we're only beginning to scratch the surface. So my friends, I hope you got something out of this. Who learned something new? Good stuff. Glad you're all here. I really appreciate it. I'm a big fan, obviously, but I'm wearing the Spring t-shirt and the Spring underwear. Obviously, I'm a big fan. But you don't have to take my word for it. I think this is cool, but there's a lot of interesting companies out there doing amazing things. I mentioned Alibaba. They're a small company in China. I think they're going to be big one day. Everything they build is on top of Spring. Everything. And I mean all their organization, all their different parts of the organization. Taobao, Aliyun, AliExpress, Alipay, Ant Financial, all these different organizations are part of the Alibaba umbrella, and they all use Spring, and they have for decades. And they all had to solve these distributed systems problems built on Spring. Now, as we have built Spring Cloud and Spring Boot, they have been moving to that, and now they're all in on Reactive. They're all in on RSocket as well. Right? Netflix, I talked about Netflix. Obviously, they're in on this. Facebook is getting in on this, right? Obviously. Large organizations that have a lot of money, the motivation, and the need to solve these problems, they could solve these problems themselves, but they're choosing instead to bet on the Pivotal Stack, to bet on Spring, and that allows them to build better software faster, to get to production faster. And at the end of the day, that really is all that matters. Thank you, Mel. Thank you so much, my friends. Thank you, WAES, for having me. I appreciate it. Thank you so much. Cheers. Okay. Let's get a selfie.
All right?
Okay, my friend. I need you. Can we get a selfie? Yep. Do you accept our GDPR cookies? Okay. Okay. Pretend like you're happy, okay? Just pretend like you're happy. Alrighty. 1, 2, 3, say open source. Open source. Oh yeah. 1, 2, 3, go. Open source. Good stuff. Thank you.
All right, Josh, super thanks for the tech talk. Very useful, and thank you for the lessons learned. Before we end up this part of the evening, we have a small gift for you. And it's because you traveled this much, we bought you something portable beamer, so you can watch all the favorite shows and program on your hotel room on the big screen.
What is this? Like a projector?
Yeah.
That's the coolest thing I've ever seen. I didn't know they had these things.
It's true, they have. So the next time you will use it, you will think about WAES and of the evening we had together.
Thank you so much.
All right.
That's so cool. That's awesome. Thank you, my friend. Yeah. Wow.
So thank you for coming. Please join us for the last part of the evening. Some food and drinks, and of course the meet and greet. And thank you for coming again.
Yep.
Bye.
So good. Thank you. Very cool.